Keeping in mind that our eventual goal in this class is algebra and working with and manipulating variables, let's look at what we call algebraic expressions. Now, algebraic expressions, like everything else, is going to be based on the order of operations.
I'll be back.
I told you that would come back. All of algebra is based on the order of operations. You better memorize it. Just in case you've forgotten, for the last time we're going to tell you, when you're faced with more than one operation, you've got to do, number one, parentheses, and if there's more than one, we'll work left to right. Then, and after all the parentheses are done, and only then, do you work through the exponents. Then, you do your multiplication and division. Once again, left to right. Now, don't think that multiplication automatically comes before division. If we have both, we're going to work left to right amongst them. And then, lastly, we'll do addition and subtraction. A lot of people want to do that first because it's easier, but you don't get to do it. You have to work through this order. And I should add, you're required to simplify any fraction. We're not going to tell you. That'll be the very last thing you do. Okay, well, let's look at some algebraic expressions.
Holy alphabet.
What it is, basically, is a bunch of letters, isn't it? Initially, it looks scary, but it shouldn't scare you because really these letters, these variables, are just holders of numbers. What numbers? Well, we'll tell you. We get to pick any numbers. That's why we call them variables, because they vary. In this problem,
Now what am I going to do?
let's let every occurrence of A be 4 and every occurrence of B be 3. So I'll rewrite the problem, and instead of A I'll write 4, and instead of B I'll write 3. Watch. There we go. That's all you have to do is put in the numbers that we tell you as replacements for the letters. Now we have to follow the order of operations. Do what's in parentheses first. Well, I see the 2 times the 4. That's what I'll do in that step. Then I do any exponents. Well, I have 2 exponents, don't I? I have 8 squared, and I have that green 3 squared. Which do I do first? Well, I do the 8 squared first. Then I did the green 3 squared. Notice I did not multiply yet. I have to do all my exponents first. So I did 8 squared, I got 64. The green 3 squared and got 9. Now, don't subtract 64 minus 3. You have to do your multiplication next. 3 times 9. Get 27. And now, and only now, do we do our addition and subtraction. Of course, we only have subtraction. And that's your answer. 37. There you go. Let's try another.
Yoink.
Here's some more placeholders. Different letters, but it really doesn't matter. There's a little bit of a different flavor in this one, though. Every occurrence of X, I'm going to put in a 7. And every occurrence of Y, note that I do have 2 Y's, I'm going to put in a 3. So I'll have to basically put in a 7 for every X and a 3 for every Y. See, I had 2 Y's, so I have 2 3's. After that, basically I'm just following the order of operations. I would do what's in parentheses first, and there is a parentheses, but there's nothing to do inside of it. So the next thing to do is exponents. I have 7 squared, and I have the green 3 squared. So I'll execute both of them. Basically, I did the 7 squared first, and then I did the 3 squared and got the 9. That's parentheses, then exponents. Now I've got to do multiplication before I do any addition and subtraction. It's tempting to do that, though, isn't it? So I have to do the multiplication of the 2 times the 9, and I get an 18. Now this is interesting. I have an addition and a subtraction, or a subtraction and an addition, and they're on the same step, aren't they? They're all step 4. I have to work from left to right now. I have to work from left to right. I have to do 49 minus 18 first, then add the 3 to get the correct answer.
And that's how she wrote.
Okay, very important. When operations are on the same level, like multiplication and division or addition and subtraction, I had to say one first. I said addition before subtraction, but that really doesn't mean you always do addition before subtraction. When they're on the same level, then you work left to right, and only then.
Oh, no you don't.
It looks like the same question, doesn't it? But this time, as I said, variables can vary. That's why we call them variables. I'm going to do the same thing again, but we're going to put in different values into these placeholders. Instead of x, I'll put a 5, and instead of y, I'll put a 2. As you can see, instead of x, I put a 5, and instead of y, I put a 2. Now let's follow our order of operations again, basically doing the same thing with different values for our variables. There's nothing to do inside parentheses, so we move on to exponents. I'm going to square the 5, and I'm going to square the green 2 only. Okay? So I get 25, and I get 4. Now I'll do my multiplication. 2 times 4. Now I'll work from left to right amongst the subtraction and addition. 25 minus 8 first. Then 17 plus 2. Then I've got an answer.
No problemo.
Okay, you've got to know that order of operations. Now so far I've been giving you the expressions. The x squared minus 2y squared plus y. Pretty soon you're going to have to come up with them. You're going to have to take a word problem and evaluate the words and translate them into math language, if you would, or an expression. There are some words and some hints that can help you.
I have a feeling some bad stuff is about to go down.
It's not that bad if you just get to familiarize yourself with the key words, if you would. The key words for addition, for instance, are the word sum. The sum of A and B can be turned into A plus B. That's not bad. The word sum infers addition. The word more than infers addition. 8 more than x means x plus 8. That's 8 more than x. The word total smells like addition, doesn't it? The total of A, B, and C means add them up. So A plus B plus C in math language, if you would. Increased by is another one. Y increased by 3. You took y and increased it by 3. Can be interpreted as y plus 3. So these are some of the words you might want to get to know for addition. How about
Pay attention, son. This is for your own good.
How about we look at subtraction? Well, there's going to be different words. A subtracted from B, that's easy. That's the exact word. That's not that easy because, you see, there's where people screw up. A subtracted from B means that I started with B and I took A from it. Even though they wrote on the left here, they wrote the green A first. Look on the right, the green A ends up being second because we're taking A away from B. The word from is a little tricky, so be careful when they have the word from. 8 less than x means I started with x. Even though I wrote the 8 first, I started with x and I have 8 less than that. There's another one like from that I'm going to have to switch it.
Correct, boy wonder.
It's going to be x minus 8. 8 less than x. That's a tricky one too. Subtraction's tough. Now the word difference will always infer subtraction. The difference of y and c, a lot of people don't know this,
Darn tootin'.
is y minus c. I always tell people I met a 7-foot tall man and I'm 5 foot tall. Now what is the difference between him and me? Well, you can picture it. It's 2 feet, isn't it? 7 minus 2, and you use subtraction. So the word difference infers subtraction. Remember that. Finally, a little more obvious, decreased by is another one for subtraction. 7 decreased by 3. Z decreased by 3 is Z minus 3. We're pretty predictable here. I bet you know what's coming up. We've done addition and subtraction.
Nerd alert!
Let's do the words that suggest multiplication. The first one, I bet you've never heard of. The word product is the answer to a multiplication problem. So the product of A and B infers, like sum infers addition, the word product means multiplication. Okay, now I can write that A times B, or I can just write AB, because when you write two things right next to each other, that means that they're going to be multiplied. The word of will always mean multiplication. 8 of x could be written 8 times x or 8x. Just remember of. I always tell people, you know those cartons that eggs come in? If you have 2 of those cartons, you know you have 24 eggs, because you have 2 of them. You have 2 times 12. You do it in your mind very quickly. But 2 of 12, so 2 times 12. So of always means times in math. Twice is an easy one. It infers 2 times something. So twice z would be written 2z. Y times 3. This one's a little screwy. Y times 3. We're not going to write y3. When we have a number multiplied by a letter, we're always going to put that number first.
Well, ooh-la-dee-da.
We always want to be writing things the same way so that your answer matches my answer and so on. So just remember, when we have a number and a letter, always write the number first. So that's 3y. That means 3 times y. Finally, we have your old buddy, division. The words that suggest division, we kind of covered a little bit. The word quotient is the answer to a division problem. So as soon as you see the word quotient, it's just telling you use division. The quotient of A and B means A divided by B, or A over B as a fraction. You could write it. Okay? This one's weird. 8 into x means you started with x and divided it by 8. 8 into x.
Just as I suspected.
It's going to be 8, is x divided by 8, or x over 8 as a fraction. This one's easy. Y divided by 3.
Very simple, sir.
Okay, that's not a problem at all. So there's ones that you have to switch around, like 8 into x kind of a thing. You got to be careful. There are going to be many that you have to switch around, so you'll have to read carefully and do the interpretation. Now we're just doing a little bit at a time here, so we'll need to get to work. Okay, you got to go get to the homework and move it.